Hello and welcome to another episode from Spiral Physics Education. This episode is a grade booster episode, and what we're going to be looking at to help you boost your grades is a sort of grade 6-ish type question using stores and transfers, linking them to the conservation of energy, and also looking at some worked examples that are a little bit harder than that, so really between sort of grade 6 and 7. So to get the most out of this lesson, it really does help if you know what stores and transfers are and all the different examples of stores and transfers, know about the principle of conservation of energy, know what energy flow diagrams look like because we're going to be completing one of those. And we're also going to be referring to stores and transfers in certain examples or in certain systems if you prefer that. So let's have a look at a grade 6 question or below or easier, and it starts off with a question asking what the principle of conservation of energy is, and there are different sections and more parts to it as well. And the second part is to identify the transfers involved between each of the stores and energy in the energy flow diagram for a ball that is rolling along the ground until it comes to rest, meaning that it stops completely. So the rest of the question looks like this. So stores are going to be presented in boxes. So the ball, when it's rolling, has kinetic energy store. The arrow represents an unknown transfer, which is part of the question. So we have to identify what that transfer is. So that kinetic energy store is transferred to thermal energy store of the ball and the ground. And then there's another transfer represented by that arrow, and that's what we have to identify as well. And then we have thermal energy store of the surroundings. So that's the question in its entirety. So let's start with how we can answer question one. And question one's very basic. It's a 1 mark. It says state. It's one of the things you either know it or you don't. So I advise you to learn the principle of conservation of energy. And that is that energy cannot be created or destroyed. It's only transferred between different types of energy stores. So we're going on to the next bit. So that's 1 mark. So we're going to the next bit, and we're trying to identify what this transfer is here, which I've labelled A. So what I'm thinking there is, well, kinetic energy, when something's moving, you always have friction. Friction is a force. And whenever there's a force present, then there's got to be a mechanical transfer. So let's try to look at B. And what I'm thinking for B is, well, now if the ball and the ground have got an increase in thermal energy store, that means they're hotter due to this friction. And that means if things are hotter than the surroundings, B must be a thermal transfer to the surroundings. So the basic examples for those 2 marks is the first transfer A is mechanical transfer, and the second transfer B is a thermal transfer. Let's have a look at a little bit harder question. So we're going to describe the main energy transfers for a bike that's freewheeling down a hill. And the question's been very helpful here. It's telling us to refer to stores and transfers. And it's worth 3 marks. So we've got to say or come up with 3 good bits of physics to get the 3 marks here. So what I'm thinking is, what does freewheeling mean? And if I think about freewheeling, it means that the cyclist isn't pedaling. So there's nothing to do with kinetic energy, not kinetic energy, chemical energy store. So the person isn't doing any work. So it must be their weight. Their weight is causing them to go down the hill. And weight is a force. So if we identify the first type of energy that the cyclist has, the cyclist is up a hill, so it has gravitational potential energy store at the top of the hill. And some of this gravitational potential energy store is transferred mechanically into, first of all, kinetic energy store of the cyclist, it's going to move, and thermal energy store of the wheels and the road. And that's due to friction. And then we can also say that some of the gravitational potential energy will be transferred by radiation. What I mean by that is sound waves. That's because it might be a little bit noisy. Something will squeak. You might hear the tyres on the roads. You're definitely going to get some transfer of energy via sound waves from this system. And then what we could also say is there's going to be a thermal energy store from the wheels and the road. And that means that they will heat up, and therefore there'll be some thermal energy transferred by heating to the surroundings, and that will always happen in every situation. So if you notice, I've used bullet points there, and it's okay to use bullet points as long as you try to link each bullet point in a logical way. So if you look at the first one, the cyclist's gravitational potential energy at the top of the hill, then the next one is there's some of this. I'm referring to that first bullet point. Some of the gravitational potential energy is mechanically transferred into, and then the next bullet point links into it, and the next bullet point links into it. It's a very logical progression. So it's okay to use bullet points if you use them logically like that, and you use some form of linking language, hence, therefore, so, etc. Don't use bullet points as a means to put down random thoughts that you have about the answer. So if we look at all the points there, if I'm thinking each bullet point could potentially be a mark, I've got 1, 2, 3, 4, 5, 6 good bits of physics there. I'm only going to get 3 marks on there, and it's a little bit of guesswork, really, what the exam board will accept. But I'm pretty confident there that I'm going to get 3 marks from all of those 6 good bits of physics that I've described there. So let's have a look at another question here. We've got grade 6 to 7 question again. It's a little bit harder because there are 4 marks this time. So let's have a look. We've got to describe the main energy transfer for a golf club hitting a ball. And again, the question has been helpful that it's telling us to refer to stores and transfers in our answer. So first I'm thinking, well, golf clubs exert forces on balls. So I'm going to have to say something about mechanical transfers in this. So that's really helpful. To start off with though, you swing a golf club and the golf club moves. Therefore, the first thing you can say is that there's kinetic energy store of the golf club. And when it strikes the golf ball, the golf club transfers mechanical energy to the golf ball because of this force. So kinetic energy store is transferred mechanically to the ball. We can say some of it, probably not all of it. So some of this mechanical transfer is going to increase the kinetic energy store of the ball. The ball was going to move. But some of it's also going to increase the ball and the club's thermal energy store as well. Both of them are going to get a little bit warmer. And because both of them are going to be warmer than the surroundings, then thermal energy is going to be transferred or dissipated to the surroundings. So we've got 1, 2, 3, 4, 5 good bits of physics in bullet points. They're linked, they're in a logical progression. Pretty confident there that out of those 5 points that I've made, I'm going to get 4 marks out of the 4 available. So I hope that you found that episode helpful and in boosting your grades and your understanding of physics. Subscribe to the channel. There'll be more ways to boost your grades and more videos on helping you to understand physics a little bit better in preparation for your GCSE exams. And I'll see you next time.